Close your eyes and picture this. You're standing on Mars. No spacesuit. Just you, your clothes, and the planet. In the first 10 seconds your eyes start to boil. Not from heat, from the complete absence of pressure. The moisture in your lungs does the same thing. Your blood begins to bubble beneath your skin. The temperature, averaging around -60 degrees Celsius on a normal day, is already working on the rest of you. 15 seconds in, you're unconscious. Under a minute, you're dead. And this is the planet that the smartest people on Earth are spending billions of dollars trying to send humans to. The planet that gets discussed over dinner like it's a real estate opportunity. The planet that billionaires have built their legacies around reaching. We talk about Mars like it's humanity's next chapter. Like it's waiting for us with open arms. It isn't. The more honestly you look at Mars, not through the lens of ambition or science fiction or inspirational keynote speeches, but through actual physics, actual biology, actual data, the more it starts to look less like a frontier and more like a trap. So that's exactly what we're going to do today. Look at it honestly. I'm Michael Alex and you're watching Vortex, where we don't dress things up to make them comfortable. We follow the science wherever it goes, even when it goes somewhere inconvenient. Today it goes to Mars. And it does not paint a pretty picture. Before we get to the radiation, the toxic soil, the dust storms or the psychological horror of permanent isolation, let's start with the most basic requirement for human life. Air. Mars has an atmosphere. Technically. But calling it an atmosphere in any meaningful sense is being extraordinarily generous. The atmospheric pressure on Mars averages around 6 millibars. Earth's sea level pressure sits at around 1013 millibars. That's not a small difference. That's not thin air you could theoretically adapt to. That is, by every practical human standard, a vacuum. Your lungs don't struggle in that environment. They simply stop working. The mechanics of breathing require pressure, your chest expanding, pressure dropping inside, air rushing in to equalize. On Mars there is nothing to rush in. The system fails completely. But even if that weren't the case, even if you could somehow breathe in near vacuum conditions, the Martian atmosphere is approximately 95% carbon dioxide. Oxygen makes up roughly 0.13% of it. Earth's atmosphere is 21% oxygen. You would be inhaling pure CO2 and suffocating while simultaneously depressurizing from the inside out. Here's what makes this worse. That thin atmosphere isn't just an oxygen problem. It's a protection problem. On Earth we have two shields working together, a thick atmosphere and a global magnetic field, forming a system that deflects the majority of cosmic radiation and solar particle events before they ever reach the surface. Mars lost its global magnetic field approximately 4 billion years ago when its core cooled and the internal dynamo shut down. Once that magnetic protection disappeared, the solar wind began stripping the atmosphere away layer by layer over hundreds of millions of years. What remained is the near-nothing we see today. The result is that Mars receives no meaningful radiation shielding from either source. An astronaut standing on the Martian surface would absorb radiation at a rate between 40 and 50 times higher than a person standing on Earth. Over the minimum 2 to 3 year mission timeline required for a Mars round trip, that cumulative exposure would exceed NASA's current career radiation limits for astronauts. We're not talking about a slightly elevated cancer risk that fits neatly into an acceptable margin. We're talking about measurable cognitive decline, damage to the central nervous system, accelerated cardiovascular aging, Real consequences written into the body by a planet that offers no shelter from the sky above it. And here's the detail that makes every engineering solution feel inadequate. Cosmic rays are so energetic they pass straight through most shielding materials. Worse, when those particles strike metal walls, they produce secondary radiation. A shower of additional particles that can be more damaging than the original. Thicker walls don't reliably help. Sometimes they actively make things worse. The atmosphere of Mars will not kill you cleanly or quickly. It will kill you slowly, invisibly, from every direction at once. Let's say you survive the atmosphere problem. You're inside a pressurized habitat. Oxygen flowing. Temperature controlled. You've solved the most immediate threat. Now look down. The ground beneath your habitat, the Martian regolith, is chemically toxic. Martian soil contains high concentrations of perchlorates. These are hazardous chemical compounds that interfere directly with thyroid function by disrupting the hormone production that regulates metabolism, growth, and basic physiological development. Any food grown in raw Martian soil would require extensive processing to remove these compounds before it could be safely eaten. Any Martian dust that enters your habitat, and it will enter, because the dust particles on Mars are extraordinarily fine, smaller than a human red blood cell, becomes a direct biological hazard the moment someone breathes it. And that dust does something else entirely beyond poisoning you. It destroys everything it touches. Martian dust carries an electrostatic charge. It clings to solar panels, reducing their output. It coats visor surfaces, degrading visibility. It works its way into mechanical seals, filters, and joints, grinding them down over time. The 2018 global dust storm that engulfed the entire planet for nearly 2 months demonstrated exactly what this means in practice. It killed NASA's Opportunity rover by blocking sunlight from its solar panels entirely. A machine that had operated successfully for years, ended by weather. Now apply that scenario to a human habitat running on solar power. Mars experiences 1 to 2 regional dust storms every Martian year. Global storms, planet-wide events that can last months, occur roughly every few Martian years. A single major storm can cut solar power output by over 90%. Your life support runs on that power. CO2 scrubbers. Water recyclers. Heating systems. All of them drawing from the same source. When power drops, you start rationing. When rationing fails, systems begin shutting down sequentially. Temperature drops. CO2 concentration climbs. And you're managing this crisis while absorbing radiation with no ability to call for immediate help, because a signal from Mars to Earth takes between 4 and 24 minutes depending on orbital positions. Mission control cannot respond in real time. There is no emergency protocol that fixes a power failure on Mars in the window between a problem emerging and it becoming catastrophic. On the International Space Station, a crew in genuine danger can be evacuated to Earth within hours. On Mars, the nearest launch window home is measured in months at minimum. And that assumes you have a functioning return vehicle, sufficient fuel reserves, and a body physically capable of surviving the journey back. That last assumption, the body capable of surviving, is where the argument against human Mars missions becomes almost impossible to dismiss. The journey to Mars takes between 6 and 9 months in microgravity. Before a single astronaut sets foot on the planet, the trip alone has already begun systematically dismantling them. In microgravity, bone density decreases at a rate of 1 to 3% per month. Muscle mass atrophies at a similar pace. The heart, no longer required to pump blood against full gravitational load, begins to shrink and weaken. Blood volume decreases. The immune system becomes less effective. Perhaps most disturbing, fluid shifts toward the head, increasing intracranial pressure in ways that physically deform the eyeball. Vision deteriorates. Some astronauts return from ISS missions with permanent vision changes. After 6 months aboard the ISS, half the journey time to Mars, astronauts frequently cannot walk unassisted when they land. They need rehabilitation measured in months just to function normally on Earth again. A Mars mission requires a minimum of 2 to 3 years. 6 to 9 months getting there. 12 to 18 months on the surface. 6 to 9 months back. When those astronauts arrive on Mars, they step into 38% of Earth's gravity. Better than zero, but almost certainly insufficient to halt or reverse the deterioration already underway. The body continues weakening. Bone continues thinning. Muscles continue atrophying against a gravitational environment that doesn't provide enough load to maintain what was there before. By the time a Mars astronaut completes the full mission cycle and returns to Earth, the skeletal and muscular damage would resemble severe long-term osteoporosis. Standing up could fracture bones. The cardiovascular system, deconditioned across years of insufficient gravitational stimulus, would struggle to pump blood against Earth's full gravity. Some researchers examining the ISS data believe the damage accumulated across a full Mars mission may never fully reverse. The body may simply never recover. This isn't theoretical. This is extrapolation from decades of carefully collected physiological data on real astronauts in real conditions. The science is pointing clearly in one direction. And then there is the mind, which may be the most fragile system of all. Every study ever conducted on isolated, confined human populations tells the same story. Even the most carefully selected, rigorously trained, and highly motivated individuals begin to deteriorate psychologically under extended confinement. Depression, interpersonal conflict, anxiety, cognitive decline. All of it documented in Antarctic research stations, submarine deployments, and ISS missions, environments that share one critical characteristic that Mars does not: an exit. In every one of those environments, the knowledge that evacuation is possible, that Earth is reachable, provides a psychological foundation that researchers believe is fundamental to mental stability over long periods. Remove that option entirely and the dynamics change in ways that current science cannot fully predict or model. The Mars 500 experiment, a simulated 520-day Mars mission conducted on Earth, documented significant psychological strain among participants even knowing they could walk out the door. Remove that option and replace it with 55 million kilometers of empty space, a communication delay that turns every conversation with loved ones into an exchange of recorded monologues, and no return window for over 2 years, and the psychological environment becomes genuinely unknown territory. So let's put everything together and ask the question honestly. Mars has no breathable air. Its atmospheric pressure causes bodily fluids to boil. Average surface temperature is -60 degrees Celsius. The soil is chemically toxic. The dust is electrically charged, pervasive and destructive to every system it contacts. There is no magnetic field and therefore no meaningful radiation protection. Global storms can eliminate power for months. The journey physically destroys the human body across multiple organ systems. And the psychological consequences of genuine permanent isolation on an alien world are largely unmapped but almost certainly severe. This is not pessimism. This is physics. None of this makes robotic Mars exploration worthless, quite the opposite. Perseverance, curiosity, ingenuity, these missions have been extraordinary. They've mapped Martian geology, studied climate history, and searched for evidence of ancient microbial life. We can continue learning everything Mars has to offer without placing human bodies in an environment specifically engineered by physics to destroy them. Perhaps the most honest thing that can be said about Mars is this: we evolved for Earth. Every biological system in the human body was shaped over millions of years by Earth's gravity, atmosphere, magnetic protection, and radiation environment. We are not adaptable to Mars. We are incompatible with it. Mars isn't a frontier waiting to be settled. It's a graveyard with a beautiful sunset. And maybe, just maybe, the most courageous thing we can do is keep looking at it from the one place in the known universe where we can breathe freely, live fully, and look up at Mars in the night sky from a safe distance of 55 million kilometers. Right here. On Earth. If this gave you something to genuinely think about, if it challenged something you assumed you already knew, then this community is exactly where you belong. Support what we're building here at Vortex. Like this video so more people get to hear the honest version of this story. Share it with someone who needs to hear it. And subscribe so you're here for every difficult question we ask next. We don't do comfortable. We do real. See you in the next one.